Okay, so this discussion is going to be focused on security architecture, which is topic two in information system security. Some of the stuff we're going to be talking about here are going to be things like architectural frameworks, um, different types of IT or IS architectures and security component categories, um, different types of security architecture implementation, and also network security architectures. All right. This relates to this particular lecture relates to NIST publication 800-160, which is System Security Engineering. Also, a couple other things to look at here. Within the SANS group out in Pittsburgh, the Security Architecture Model Component Overview, as well as the Information System Security Architecture. Basically, these are both models that have been put forward by the SANS Institute dealing with security architectures. All right. So this idea of a security architecture is really a subset of a kind of a broader idea of systems architecture, systems engineering, systems architecture, of which information systems or security architecture is a subset. All right. So as we describe it here, system security engineering is a specialty engineering discipline of systems engineering, right? A particular focused area. Covers a wide number of different areas. So, scientific, mathematical engineering, measurement, a variety of different things that are all kind of come together to create a, applied with the objective of information system security. And really, we'll look with any architecture. So this is actually what we would say about any architecture. It provides a fully integrated system levels perspective of a particular aspect of information systems. In this case, we're looking for a systems level perspective of system security. So kind of as we look here, kind of a broader picture here of systems engineering, and then specifically system security engineering, with things breaking out here. So this is actually kind of adapted from a presentation that was made back in 2014. But this is kind of a broad conceptual model. This is really just another perspective of that, the idea of an architectural framework, an engineering framework, where you have a problem, a solution, and then ultimately evaluation of what that trustworthiness is. So the idea is, problem starts off with the definition of security objectives and requirements. What is your very different measurements of success. And once you have that, you can actually develop a solution. Right? And actually, this can be really kind of iterative. So the idea of a problem, defining a problem, solution. A lot of times you don't know what you don't know, so you kind of define a problem, work on the solution, realize that you really need to maybe redefine your problem and come back through. As the solution is completed, as it's done, then what you do is that thing gets evaluated in terms of its security properties and characteristics. So you kind of see a similar thing here. So the problem, the solution to trustworthiness evaluation is an ongoing process. Right? So it's not straight linear. It can have many loops, as we call it here, a closed loop feedback, and continuous improvement. So the idea is you don't necessarily target to get 100% right the first time. You come in, gain additional insights and understanding, and then come back in again. So the definition, when we talk about what is an architectural framework, basically in its simplest form, highest level, it's a method of creating an integrated system. All right. An architectural framework is not an architecture in and of itself. It's a means by which you create an architecture. All right. So it has things like tools, it has vocabulary. Architecture is really specific to each organization. Has its own architecture, which reflects both the technologies, the business processes, and kind of how organizations do things. So there's no two organizational architecture should be considered 100% the same. Everybody's got a little bit different. Frameworks also contain things like practices and procedures and there's a bunch of vendor products out there. So the idea of these frameworks really are just really a toolkit or a set of methodologies to create an architecture. A couple of examples that are out there, better known ones in the enterprise architecture world, something we call TOGAF, which stands for the Open Group Architectural Framework, which is basically it's a methodology or architectural frameworks specifically designed to assist with enterprise architecture. So the idea of kind of a global architecture describing the entire, both technology applications and businesses. The ITIL, IT Infrastructure Library, ITIL, is another architectural framework really designed around, this is around computer processes, computer operational practices around with technical infrastructure. This is kind of, it deals with your operation, the operation side of things. From a security perspective, we have something kind of which is of a similar nature to both TOGAF and ITIL, something we call SABSA, all right, which is the Sherwood Applied Business Security Architecture. And really what it does the same thing. It gives you a set of tools and processes and guidelines that, when you apply them to your particular organization, you can develop a security architecture that matches what your organization's particular requirements or characteristics. There's 6 layers to the SABSA. All these things are, all these architectural frameworks are really kind of focused on things like structure and, kind of design. Because really what it is, it's a model around the stuff. So the 6 for SABSA: contextual, which is kind of a business perspective; conceptual, which is a high-level view; a logical and physical. So how logical is focused on how services are defined and used and how they relate to each other. Physical is actually how those services are constructed and how they interact with physical assets. Components, and then finally operational components is really what the view of all the components and the individual services. Finally, the operational view is really kind of all the operations and services kind of put together. So the idea is you have different perspectives and different views around these things. So a lot of the terms you hear in the architectural framework, because we also talk about this in TOGAF, is this conceptual views, logical views, physical views, component views, field manager view. So it's this, you describe the whole, but you describe it with a kind of a different perspective. Some things are more focused on, like with physical, you're going to be talking more about components and kind of the technologies and stuff, as opposed to the logical, which is more kind of a little bit more abstract. Here's kind of just to give you a picture of kind of what this thing looks like in a kind of a two-way matrix. The idea of here's our 6 layers here, contextual, conceptual, logical, physical, component, service, and then a kind of matched up against the what, where, what, why, how, who, where, and when characterization. And the intersection of both of those really describes something that's within that particular domain. So this is what's used in SABSA, but this could actually be applied in any number of other kind of architectural domains. It's really, as I said, it's really a tool, really a framework, really something you can use to help organize and structure your planning processes. So IS purpose, so the IS architecture purpose, really it's, the idea is what we're looking for is the different qualities. We'll be defining a set of qualities, and then requirements. So in this case, we're talking about, say, security requirements that are needed to support an organization in achieving its mission. All right. So one of the key things that, in particular with security, which is not always historically been the case, but one of the key things about security is that it really needs to be an intrinsic aspect or characteristic attribute. Security needs to be an attribute of whatever particular object we're talking about. So it's not a lot of the big challenges of security is that security was never designed in; it was added on afterwards, always challenges with gap fit and trying to make sure you cover everything. All right. So the idea of an organizational security policy is really the definition of those policies drives what the actual requirement should be. So you don't create requirements out of nothing. Basically, you create policies, and then from those policies, you derive a set of requirements. Different models. There's a bunch of different models, security model techniques. But really, what its purpose is to take these relatively abstract security policy goals and bake them into an IT architecture. All right. So it's really just a means of being able to capture, organize, and then align it with what this overall architectural model is all about. So the systems architecture, as we defined here, is an overall design, components. So it's we throw things, stuff we've talked about before, the different aspects of information technology, hardware, operating systems, applications, networks, kind of combined together. But with a particular, in this case, what we're looking at would be a particular perspective of this stuff as it relates to security, because security is should be considered an intrinsic part of that the characteristics of that object. There's a couple different things, a couple different types of architectures that we talk about. So this is we see this all the time. But my area of focus has been in the past couple of years is around enterprise architecture, was kind of a big picture view of kind of across the board. Network architectures, describe different entities and kind of how they talk to each other, how many different components, how they're organized, how things flow through them. A lot of times with network architectures, a lot of the stuff have been focused on with things like firewalls and intrusion detection systems and things of that nature. Platform architecture really describes all of the different types of devices, the characteristics of devices, stuff we've talked about in the past. So storage, memory, CPUs, capacity, operating systems, and then finally this other perspective of security architecture, how protection mechanisms and security models are used inside each of these inside each of these areas. And then security, all of these three fall under this kind of umbrella of an enterprise architecture. So a couple other terminologies we see here, systems, security, engineering. The idea of applying engineering principles to identify security vulnerabilities. So and using this as a mechanism to try to establish risk management, which is, as we've said before in the past, that this is risk management is one of the key issues that we strive for in security. Different protection mechanisms, so we use to protect the systems. What are the particular tools that we use within this stuff, to actually implement protection, and then different security models. So how do we integrate security into a systems architecture? So here's a kind of a lot of the stuff tends to be a little abstract, but here's some of the different security architecture design principles and how they are actually implemented. All right, so these are different principles. So clear abstraction, least common mechanism, reduce complexity, secure evolvability, and trusted components. And these are we have in this column here is basically the means by which these things get implemented. So security architecture theory, so there's a theoretical base around this stuff. It's all just not practical, just practical implementation. There's a theoretical base around a lot of this stuff. So some of the stuff we see here is like state machine models, trusted computing base, monitor and security, reference monitor, security kernel, and resource isolation. So these are very technical aspects of security that we're seeing being looked at and kind of being built in both in its theory and as also its practical applications. So the big things we focus on this stuff, the big things are its detection, prevention, monitoring. So the idea is, detection. You got to know something is happening. Um, Prevent, and actually, from a attacker's perspective, being undetected is really their objective. Prevention. The idea of prevention is, to deter potential intruders from even attempting. Monitoring, so is kind of aligned with detection. So you monitor, looking for situations which you detect, but also monitoring is also has broader applicability. Detection is kind of a subset of, operates within the domain of monitoring, but monitoring is kind of an overall, the big picture of everything you're looking at. So it's, assessments of how things are going, whether the goals are met, policies are being enforced, and then recommendations for how to improve. Some other pieces within this management. So there's a couple of things within management that we focus on. So change control, which is actually a pretty big piece. Once you establish a baseline of anything, from an architectural perspective, managing change, introducing modifications, changing the way relationships and stuff, is something that has to be very tightly controlled. Because what happens is uncontrolled change basically can easily make things blow up. Right? A lot of these systems and networks and integrations that we've got out there are fairly brittle. So they're not really. They need to be. Changes need to be introduced very carefully and tested and verification. So this whole change control process is a big thing. Compliance monitoring is another piece of this. This idea of reviewing components of making sure that things are doing what we say they're supposed to be doing. So it's a lot of taking what you've established as your baselines and then performing measurements against it and trying to identify, okay, how good are we? Are we managing things? Are there gaps? Are there ways we can improve things? So security and the implementation, bunch of different, there's a bunch of different pieces around this. So it's really, when we start off with kind of a description of the locations where measures need to be placed. So that and those refer to actual locations. When we talk about locations, like what components, what components talk to what components, and kind of what are the security aspects of all those things. How they act. In addition, we want to talk about how the components talk to each other, interact with each other, to make sure that they are secure. One of the big challenges you see is the integration, the interconnection between components is an area that that's an attack area. That's an area of potential vulnerability, because you've got two things are kind of talking to each other. So could that be possibly adapted or used or manipulated by an attacker? All right, and then specification, security specifications will be followed when designing. What are the specifications that we're going to be using around this? So there's a bunch of stuff that's within this, and a bunch of stuff we'll see within these security architectures. So the idea of users and groups, which is who is who, and kind of what do they do, and then what resources do they need to access to do their job, which is a pretty big task. Because what happens is what happens a lot of times with organizations is you're not managing individual users. Actually, what you want to do is you want to kind of define groups, and the characteristics of groups, and then kind of put individuals into those groups. Other things, monitoring shared directories, physical security, which is always a consideration. Dedicated systems for dedicated services, and then finally this idea of operating systems hardening. All right? So operating systems in and of themselves will usually have a fair amount of capability to be able to around security. However, it is not necessarily installed. It is not actually all implemented, and it also has to be maintained and sustained. Right? So this idea, the three dimensions of this are, be able to, establishing the appropriate, operating systems installation, the configuration of those systems, and then also patching, ongoing. The idea of an ongoing, living security, a patching program, which is tied into what your security model is all about. A couple other things we see within network architecture, secure networking, isolating user populations and controlling access, which I think are two similar things, but they're very, but they're once again very important. What you want to do is you want to make sure that nobody really has unrestrained access to move across the entire network without being monitored and tracked. All right, and then also doing within that kind of restricting access, in terms of systems, connectivity devices, network segments, physical security. Basically nobody, anybody who's moving or doing activities, at any point within there you should be able to get an understanding of what their activities are, whether their activities have been approved or validated or not, and kind of what's happening. So that's so the restricting access is a big part of defining what we set up in our network architecture security. Gateway security, so things we're looking at. This is when we've talked about like firewalls and monitoring traffic, and also monitoring. We talk about content filtering, we talk about virus filtering, but we also have things like activity monitoring, making adjustments, detecting looking for particular patterns of behavior, which could possibly be indicative of some sort of malware or some sort of bad actor on the system. So there's a couple different types of tools here, a couple different ways of implementation. So talking about Ethernet routers, combining functions. The idea of what you want to do on the network side, you really want to see what's going on with the packets. Where packets coming from, where are they going to, and what's in those packets. All right. So a lot of these specialized kind of tools, the switched Ethernet routers, are kind of a specialized type of switching mechanism that will basically enable you to monitor and track traffic as it's moving. Right. Multiple firewalls. So that once again, as we talk about this kind of monitoring traffic as it moves from place to place, the idea of having, you do not have unrestrained access to get to any server, any location in the network. Something has to flow through some sort of firewall, and that traffic can be monitored. Also similar to that, we talk about intrusion detection systems, which is another layer of monitoring traffic, watching traffic, analyzing traffic, and trying to get insights into what's going on with that, what that traffic's up to, and kind of what's happening. Talk about VPNs, virtual private networks. We've talked about this if you were in the network class. We talked about what a VPN is, which is basically a secured tunnel between two endpoints that let you be able to pass in from an internet to an intranet, but it's encrypted and secured on both ends. Host and end-based security, which is really the name of the game in terms of most modern systems. The idea is what you want to get to is that every device, every component, every what we call either host or as we call it endpoint, needs to have some sort of security mechanisms that's appropriate for what it's being used for. All right, and then being able to manage that security, on an ongoing basis, understand what it's doing, what's happening, what are activities. That's really the challenge within within network security. And then this is really the network security architecture, really a model of how you do all this stuff. Finally, about security models. So models is a whole bunch of different types of models out here. I'm not going to go into to in depth with all of them. They each have different functions, different uses. A lot of this stuff is the modeling is being done, say, on a mathematical basis. And what it is used for is to identify things such as, basically how to get, protecting data. So the ability to kind of create a model that would show you who has access to what and to what degree particular data is being protected, and be able to express that in terms of a model. So formal models are based on kind of mathematical implementations. So these are fairly complicated, sophisticated types of systems. Informal models are basically not quite as rigorous, but they specify how to express and execute different policies. So these are some of the different types of models. So we'll talk about state machine, Bell Padula, Biba. So the idea of being able to create a model in which you can make sure that data, the integrity level of data is maintained, or as it moves from state to state. So you can see these are pretty. I said these tend to be very complex implementations. Some other ones here: Clark Wilson, Lipner. Lipner. Some of these things become combinations. So things like, for example, a Lipner model actually focuses both on the confidential integrity of data, and what it does is actually combines takes bits of Bell, Padula, and Biba, blend those two together with different job functions. Harrison, Rousseau, Ullman, and ACL. So ACL you just see a lot of. ACL is a fairly common term where basically what you do is you have a list of, for every resource that's out there, so we'll say, for example, a file, there's an ACL, which is an access control list of who can do what to that file. So it's a read. Usually it's like read, write, create. If we're talking about like a data file, it's read, write, delete, and create. And basically that's the subject, and then the access permissions of who can do that. So if you have permissions to create a file, you have that permissions to create it to actually create it. You have that permissions to delete it to actually delete it. And then everything is identified and tracked against that. So everything is held accountable when you set this stuff up in ACL. If you have rights to it, then basically whatever the outcomes are or what activities are applied against it, can be tracked back to that particular, whoever has access to that. And just a whole another set of these additional models. So this is really just to give you kind of a high level picture of kind of what these different, kind of how these things are constructed. Another thing we see in terms of security inside of like systems, this is actually being done at the secure addressing, which is actually activities that are done within a CPU. So this is really low. This is at the machine level. So this is actually getting into the instruction, activities involving with instructions. What are the instructions? What's happening within the execution of an instruction, and whether or not kind of what is whether there is an appropriate security associated with accessing certain memory addresses or certain processors or certain registers inside of the system. So absolute, direct, implied addressing, index addressing, indirect addressing. So the idea of controlling this stuff. This actually, once again, is it's an interesting area because it's what we're seeing is historically there was not a lot of attack vectors kind of at lower level, at the process level. We're seeing more and more that's becoming a target area of choice. So what you do is if you can compromise microcode, you can basically use that and interject your own, an attacker can interject their own executables well down at the machine level. So this idea of secure addressing and kind of being able to track things like that is it's a growing area. Operating state, kind of in a similar fashion. So this is dealing with operating systems functions, ready, supervisory, wait states, problem state. So this is all activities that you from a modeling perspective, understanding what these are in terms of security. And then machines. So there's a different machine types out there. Traditional, we call real machine, is like a PC. Real PC, PC is a computer uses memory and CPU to run a single application. Your kind of traditional computer. You have multitasking machines. Actually, you can run multiple. You'll be able to take a single machine. But most things would kind of run either like a multitasking or multi-user kinds of platforms, like servers and things like that, are generally if you're some type of multitasking, multi-user types of machines, like Unix and things like that. Virtual machine is relatively new, so they've actually been around maybe 17, 18 years. But VMs, as we call them, virtual machines, is really kind of the mainstream technology right now with computing. What you do is the idea is you take one very large machine and then chop it into a bunch of smaller machines, um, which is interesting because what happens is, from a security perspective, um, what you've got is as you concentrate more and more compute um, assets into one device, if you compromise that one device, if you compromise that virtual machine, virtual machines run on something called a hypervisor, which is basically a thin layer of operating system code which is responsible for kind of controlling and coordinating activities across different VMs. The idea, if you can compromise the hypervisor, basically you have control. So if there's 1,000 machines running inside of a physical machine, and you can compromise the hypervisor, you've compromised all 1,000 machines. So it's an area, once again, from a security perspective, of areas of concentration. Different types of storage. This is all different types of, and we've talked about this in other areas. Basically primary, secondary storage is real memory, which is where basically computers do their where we store and store activities, volatile, non-volatile memories, things of that nature. So all these things have potential security dimensions associated with them. And that is everything we need to know about security architectures.